Hey Shagvi, how are you?
I'm good.
What are you doing in school, ma? I'm so curious to know.
We're doing logarithmic functions.
Oh, that's exactly what we are doing too. I'll just continue. And what is the ending? Semi-log plots, huh?
Yeah.
Okay. Do you have your calendar, ma?
Yeah.
Just send it. Send it to me, all the 9 week calendar. Just send it to me.
Okay.
That really helps me.
Okay.
Ma, whatever we are doing here, is it helping your school, ma, Stragvi?
Yeah, it is.
Oh, good to know. Lopa, how about you, ma? What are you doing in school?
We have a test on Monday over I forgot what it's called, like the geometric and arithmetic sequences.
Oh,
And
exponential function. Okay, good. Go ahead. Do you need any help? Do you want me to review that?
yeah, if you could review it, that'd be nice. I have a test on Monday, so
Yeah, it doesn't Monday. On Monday, okay. Okay. Reviewing or giving an assignment on that would help. What would help you better?
no, yeah, like if I could just have extra practice over, that'd be good because
Ah,
my teacher
I'll
doesn't.
assign it.
Yeah, my
So
teacher doesn't really give practices.
I'll get you a test. But can you send me what are the topics for the test? I'll prepare one and send.
Okay, thank you so much.
Yeah, but send it to me definitely. Let me help you to some way. Parvini, how are you, ma? What are you doing in school?
We're also doing like log.
Okay, okay, see if it is logarithmic exponential functions, I'm happy. I'm doing the same thing. I want to end with semi-log plots. How about you, Krish?
It's also logs.
Okay, do you have that 9 week calendar, Krish?
Yeah, I can send it.
Yeah, please send you and Shagvi. And are you using what we are doing here, Krish, at school?
Yeah.
Okay, okay. So see, we were discussing uh, some of the graphs right last week, so I'll continue discussing. The plan for today is I'll continue discussing those graphs of logarithmic functions, then I'll work on logarithmic functions expanding and condensing. Remember we studied in algebra 2, they were all easy. This is going to be a little intense. Okay, so after that I would go ahead with regression curves. After that, I would go ahead with logarithmic inequalities, and then we will discuss logarithmic regression, and then we'll go to semi-log plots. Honestly, I don't know whether I can complete it today, but this is the sequence we are going to follow till semi-log plots. Did you send them, Shagvi?
Yeah, I did.
You did? Okay, I don't have my WhatsApp open. Let me see. Okay, let's move on. One second. Oh, you send me a file. Okay. Oh, semi-log plotting is November 5. Oh my goodness. Have they done the semi-log plots, ma?
Yeah, we did it today.
You did it?
Yeah.
Oh my God. 2.15. Okay, see, that's what I want to end with. Okay, let's see. Okay, so next week schedule, what is it, ma? From November 11th?
I don't know. She didn't post that yet.
Okay, this is exactly what I'm thinking of doing. For them, function manipulation. See, semi-log plots is not even coming till next week for Krish. You guys are a little ahead, ma. Okay, anyway. November 30. Okay, for Krish, it's very much beneficial. Whatever we are doing is 1 week ahead. Okay, that's good. For Shragvi, semi-log plots, I will try because it's a lot to cover in one class. So let's see. But it's an easy one and a very impressive one, I feel, semi-log plots. Let's see. Sushank, what are you doing in school?
Uh, Today we were learning about how like geometric sequences are related to exponential graphs and then how arithmetic sequences are related to linear graphs.
Oh, okay. But yeah, that's an easy topic. Can I say like that?
Yeah, it was pretty easy.
Okay. Are you able to use anything that we do here, Sushank, there?
Kind of. The thing is, I asked my teacher like why our school is kind of ahead in pre-calc. Like we're on unit like 5 or unit 4 or 5 already. And she said what they did is we're currently technically on unit 2.2, but they cut it up into smaller units so we can go quicker.
Uh, you think they are faster? No, right, Sushank? Meaning we are discussing inequalities, logs of inequalities of exponential and log. I feel like, see, if you are on 2.2 now, we are on 2.10, right? Right, Sushank?
Yeah, but we've been skipping around. Like, for
You,
example,
yeah. Agree. You're, yeah. In your school, they've been skipping around. Correct. I agree. I agree. It's not like in the same sequence they're going, right? I do see that the others are matching. But is it working for you at school?
yeah,
It's the same AP. Okay, I hear you. You will get to these for sure. Okay, let's go ahead. Uh, Ashrit, I wanted to talk to you at the end of the class, Amma.
Yeah.
Okay, we will definitely talk. Mana, what are you doing in school? I spend a lot of time on this, man. Just tell me and go, Mana. What are you doing in
We're
school?
doing exponential logarithmic functions.
Functions. Okay, that's the same thing. See, for Sushank only, as you said, they're skipping around. Let's see. Let's see what we can do. But if you need any assignments or help with respect to whatever you're doing, you can ask Sushank. Okay.
Okay.
But Sushank is the only one. It's a little off for you. But let me know, Sushank. I'm happy to help anytime if you come up with something that you need. Make sense? Hey, Siddhi, what are you doing? You're so quiet. You did not
We're
even say that I didn't ask you.
we're doing logs, our unit on logs and like residual plotting.
You're doing what?
Our unit on logs and residual plotting.
Oh, I see. Oh, residual plots. Okay, you are at the back. Interesting. Okay.
Let me check which AP topics it is.
I see. Okay, makes sense. Okay. When are you all having your AP exam this year? Do you know?
Miss Priya, I'm doing topics 2.6 to 215.
That's nice. 2 point, see, today we are going, I am thinking of covering, we are on 2.11 since last week, but I did not complete, so I'll get going with 2.11 and try to go till 2.15, but at least if I want to, if I complete 2.14, it itself is great is what I'm thinking. Okay.
Okay.
So let's continue with this. 2.11. What were we discussing? Let me quickly check.
Also,
Document.
Miss Priya, you asked what day we have the AP exam. I think it's the 8th or the 12th. I think it's the 8th.
8th or the 12th of May,
Yeah.
May.
Mm.
Oh, we have a lot of time. Okay. See, AP pre-calc is relatively very easy, meaning, see, right now, if we complete semilog plots, right, so that completes unit 2 and 2 more units, that's all. Those are the only units that will be tested for your AP pre-calc exam. Though you have 2 more units to cover, most of the schools are not covering that. It's interesting, but that's what it is. They don't cover the extra units that are not assessed in AP pre-calc exam. Even plain OSD did not cover last year. Okay, you have to give me 1 minute. Okay, I don't know what is going on. 2.13 to 2.15 is okay. Give me 1 minute, guys. 2.13, yes. Okay. Something feels so wrong. Okay. Guys, I'm a little lost. Give me a minute, guys. Inverse of exponential functions. That's what we were discussing. Okay. So we were covering the graph. Remember, an exponential graph and a logarithmic graph we were covering. Basically, they are inverses, right? So you can just change the domain, change the range. The domain becomes range. Let me quickly do that as a review piece. Exponential function, logarithmic function. So here I'm going to write it for log base bx, any base, let's say. Log base b x, so y will be equal to, or f of x is equal to log base b, log x base b. Here the exponential function will be, let's say, b power of x. I'll take it as b power of x, or f of x equal to b power of x. So when you think about it, it's going to be 0 comma b here, right? Okay, here it's going to be something like this, right? When you think about it, this is the x equal to y line. So log will be the reflection of b power of x function over x equal to y. Since the logarithmic function is an inverse of the exponential function, when you reflect this graph on the line x equal to y, what do you get? You get something like this. So that's what shifts here. Okay, having said this, you all know this already. Let's see what is the x-intercept of both the graphs, y-intercept of both the graphs. Let's see. What is the x-intercept of this graph? Let me write it down for you. What is the x-intercept of this graph? Not applicable, right? What is the
No.
x? What is the x-intercept of this graph?
1,0.
Uh-huh. So it just switches here 1 comma 0, and then the next one y-intercept. Oh, I'm not able to write, guys. 1 comma 0. What is the y-intercept of this graph? 1 comma 0, right? Something feels so wrong. 0 comma 1, right? Y-intercept is not applicable. There won't be any y-intercept, right? Then the next one is, what is the asymptote? Asymptote, what is the increasing? How it increases? What is the asymptote in this graph? Increasing in, okay, how does it increase? Whenever b is greater than 0, it increases, right? What is the asymptote? Y equal to 0, correct, guys? What is the, I'm sorry, what is the asymptote of this graph? What is the asymptote of this graph, guys? What is the asymptote of this graph? One of you can say, right? Krish, do you know?
The left one or the right one?
Right one. Left one is written. Right one is what we have not written.
The asymptote is x equals 0.
Yep, x equal to 0. Increasing interval is again b greater than 0 here as well. If the base is greater than 0, automatically it's an increasing graph. Decreasing would be the same. Then we'll write the domain and range. What is the decreasing interval here? B less than 0, meaning whatever is to the power, right? It's less than 0. If the graph will end up as a decreasing function when b is less than 0. The same thing applies to both. And then what is the domain and range? What is the domain of this graph? What is the range of this graph? So Shank, you want to say? What is the domain and range?
Um, the domain should be infinity, like all real numbers.
It is, domain is, it's applicable for all x's, right? So minus infinity to infinity maybe. Since this is an inverse function, I can copy the range here, right? Minus infinity to infinity, because it will extend from here to here on the y-axis, right? Keeps on going up. Now, what is the range of this function? 0 to 0. 0 is not included, right? 0 to infinity. So the domain of this function would be 0. 0 is not included to infinity. Any questions, guys? Any questions on the comparison? Okay. Now, let's go ahead and see how the transformation of this works. we will want to answer one question. Okay, let's say in a logarithmic function, understanding the graphs of logarithmic function becomes a little definitely difficult when compared to exponential function. So let's consider a logarithmic graph. I have not asked any questions or anything. We are just reviewing, right? We will go there. Okay, let's say here. Okay, now this is a logarithmic graph. Okay, so here when you think about it, this is 1, 2, 3, 4. Okay, so I would call this function with the base b, and let's say, let me write down f of x equal to log x base 2. Now for this function, let's understand when will we would like to answer the question, what transformations will affect the domain? What transformation will affect the domain and range? Let's try to answer that question. What are the transformation in this function that is going to affect the domain or range? What transformations on this function will affect the domain or range? For that, I'm going to consider all possible transformations of the logarithmic function. That way, we revise them as well. Translations, dilations, and reflections. Translations, dilations, and reflections. Let's say we translate it. So what would happen? Translations can be up or down, or left or right. Is this going to affect the domain or range? Now, if it is up or down, right? So let's say by 4 or whatever, any number, if I say, right, up or down means it's going to be +4, or it can be 4 is the number of units it's going up and down, I am assuming. So it can be like this. Or if it is going to shift left or right, right? So one is going to be this, one is going to be this. How about what is this? What is this, Ma? Shragvi, do you know? The function will, what is the transformation here? X plus 4 means
It
to the
goes
left or
left
the right?
4.
Huh?
It goes left 4.
Left 4. This is right 4. This is up 4. This is down 4. Now, does this affect the domain and range? Here, this graph is for this function. Okay, when the graph moves to the right by 4, when the graph moves to the right by 4, it becomes this, right? When the graph moves left by 4, does it affect the domain and the range? When the graph moves to the left by 4, right? So what happens? 1, 2, 3, 4. The graph becomes like this, right? Now, this is horizontal translation. Graph moves to the left or right 4, up or down 4, let me draw. Up or down 4 means what will happen? Up 4 means what would happen? 1, 2, 3, 4. The graph will move like this. Okay. Or down 4 means the graph will move like this. So does it affect, okay, the horizontal movement, does it affect the domain or the range? Horizontal movement of the graph, does it affect the domain or the range?
Domain.
Yes, this affects the domain. The up or down movement affects what?
It doesn't really affect the range.
Absolutely agree. So the horizontal translation. So we wanted to answer this question, right? So the domain does get affected by horizontal translation, number 1. Whether it is left or right, it is affecting the domain. So horizontal translation does affect the domain of a logarithmic graph. Second, I said we are going to cover each one by one, right? Reflection. It can be on x-axis, y-axis. The last one, what did I say? Dilation. Dilation can be vertical or horizontal. Vertical, horizontal. It can be compression. It can be compression or stretch. Here it can be compression or stretch. if you are not understanding any of these, right, even if we have discussed this before, it's important that you quickly ask. When it comes to dilation, right, let's see. Dilation, vertical compression. Now, I'm going to, we'll do the reflection at the end, okay? Dilation, let's say vertical. Vertical means a number needs to be multiplied in front. That number, if it is greater than 1, it's going to be a stretch. So let's have the same 4. Okay, 4 log x base 2. It can be like this. Or compression, it can be 1 by 4 because it has to be less than 1. Then only it will be compressed, the log. So this is vertical compression by a factor of 4. This is a vertical stretch by a factor of 4. Now, same thing, if suppose I have horizontal compression, that means what happened? Horizontal compression means it will be 4x log base 2. Horizontal stretch means 1 by 4x. Right? So here when you think about it, will the dilation affect the domain or the range of the function? Will dilation, vertical, horizontal, compression, stretch affect the domain of the function? Anybody please shout out, guys. Sahil, do you want to say, will it affect the domain or the range?
I'm not sure.
Okay. Shragvi, do you want to think out loud with me? Yeah, go ahead, Siddhi. Okay, let's start drawing the graph for this one. Our original graph was this, right? Now, by multiplying by 1 by 4, right, what happens? It does not affect anything. When you think about it, it just goes up. The range is never getting affected. And if you multiply everything by 1 by 4, right, only the y values are going to change completely and they are going to be multiplied by 1 by 4, correct? So the range will never get affected because of this. Here as well, it affects the range it is not going to get affected. Whereas for this one, right, x value is going to get multiplied by 4. Log base 2, see here it's going to be horizontal compression or horizontal stretch. So here again, how there is no way it is going to affect the domain or the range because the graph stays in the same place. Only here the y values are going to go up or down. Here the x values is going to move a little left or right, that's all. So but it is not going to, meaning the entire domain or the range is never going to change in any of these. Coming to the reflection, right, Shragvi, do you want to think out loud with me?
Okay.
Reflection on the x-axis, let's say, let's go back to our original figure. Now reflection on the x-axis means what happens? Reflection on the x-axis means the graph becomes this, right? Will it affect the domain or the range?
The domain.
It affects the domain, Amma. X value is always 0 to
Oh, the
infinity.
range.
It affects the range. Good job. So reflection on the x-axis does affect the range. Reflection on the y-axis. Let's cross this out and see reflecting it on the y-axis. If you reflect it on the y-axis, what changes?
The domain.
The domain changes. So definitely both the reflections are affecting. So I can say a reflection on, to answer this question, it can be reflection on x-axis, y-axis or horizontal translation. Horizontal translation always affects the domain because it's horizontal. Reflection on the x-axis affects the range. Reflection on the y-axis affects the domain. Any questions here? Sahil, did you get that?
Yeah.
Okay. Let's see, horizontal. We answered the question, domain or the range. Okay, so translation and reflection, we were clear on that. Okay, that's good. Okay, Now let's see this graph. I really want you to tell me what is the asymptote, domain, and asymptote, domain, range, and end behavior for each of these questions that we are going to do. So let's go ahead and do ln of 4 minus x. Let's do one by one. Ln of 4 minus x plus 2. Ln of 4 minus x plus 2. I'm going to delete everything off here. Ln of 4 minus x plus 2. So you're going to tell me the domain, you're going to tell me the range, and then you're going to tell me the asymptote and end behavior. Can I try, please? All of you, you can do it in chat. You're going to tell the domain range. Once you do, then I'll help you to see one option to understand the domain or the range of these functions, right? See here, you need to have x minus. So for that, you need to take out this minus and say what it is. Verbal description first you need to say. Okay, maybe this one I'll do. The next one I can give it to you is what I'm thinking. Okay, this one I'll do. Now, let's say this one. How about this? Okay, now I will rewrite this function. This is my f of x function. I will rewrite this function as, let me take out, this is ln, so this is log base e is what is in there. However, I'll take out a minus of it and then I'll write it out as x minus 4. I'll write it like this and then a 2. Now I will try to write out a verbal description. This minus is a reflection on y-axis. Reflection on y-axis, and then this minus 4 is move right by 4 and then up by 2. So having said that, my logarithmic function, the parent logarithmic function is this. Reflection on the y-axis puts it in here. So first I did this reflection on the y-axis, that is number 1. Number 2, I move this right by 4, in the sense 1, 2, 3, 4. I move this right by 4. Okay. And then I also move it up by 2, in the sense, let me redraw. So first of all, the function becomes like this. Okay. But I want to move up by 2. I did not calculate that, right? So if I want to move it up by 2, so it has to cross this one. So any questions, guys? So this will be my final graph. So that being the case, now can you tell me what is the domain of this function? Who can tell me the domain? See, one of you please. Sushank, go ahead and tell me what is the domain of that function.
Um,
I showed
0
you.
to infinity, right?
Domain of the function, ma? Why 0 to infinity? Guys, if you're not understanding, you have to stop me, right? Okay, what is the domain of this function, Sushank?
Oh, that's what I was saying. Oh, I didn't know you meant
Oh
on
yeah,
the right.
that's 0 to infinity. But this one, for the final graph, what is the domain?
Oh, sorry. For this one, it's negative infinity to positive 4.
To 4. So both are not included. What is the range of that function?
All real numbers.
Minus infinity to infinity. What is the asymptote?
Um,
X equal to
4,
4. Yep. What is the end behavior?
up, down.
Uh, what is the end behavior, ma?
Like, do you want like the do you want like a limit statement or
I want a limit statement. Yes.
okay, as x approaches negative infinity,
Uh-huh.
um, f of x is
F of X approaches, can I say infinity?
yeah, positive infinity, and if when
Uh-huh.
x
X
approaches
approaches
infinity,
4 minus, can I say? Because 4 is the end, right? 4
oh
minus
yeah, 4 minus, it'll be
to minus infinity. Makes
yeah.
sense? Yep. So this is how you describe the end behavior. Any questions on this?
Miss Priya,
Yeah, go ahead, Parvini.
sorry, can you show me how you like went to the right forward up to from the graph?
Yeah, sure. So this is our base function, right, ma?
Mm,
Now, first one is a reflection on the y-axis. So literally, see here it is. So here it will come. Correct, ma?
Yeah.
Correct?
Yeah.
That is the reply. This is done. Number one is done. Number two, write by four means think about it. This one comes 1, 2, 3, 4 units. Correct, ma?
Yeah.
Does that make sense?
Yeah.
The asymptote. Where is the asymptote? This was our asymptote. Remember? So that moves 4 units means 1, 2, 3, 4 units. The asymptote is in here. You see?
Oh, okay.
So
Because
my
I
graph.
was confused because on the exponential function, the asymptote would be like the 2, right?
Correct. Correct. So here it is going to go like this. Correct, ma? But
Yeah.
then there is also one up by 2. So this point moves up by 2. It goes here. Make sense?
Yeah.
Now it will be like this.
Okay. Thank
Okay,
you.
what this distance will always be 2. Make sense?
Yeah.
Okay, so from there you can write out the domain and range easily. Writing it in a format you understand and writing out the verbal description is so important to find out anything related to the graph. Okay, how about this? Can you do it for me? This one, minus 2 log x minus 2 base 3. Minus 2 log x minus 2 base 3. You think you can do?
Miss Priya, is the domain range and asymptote, right?
Yeah.
Okay.
Let me ask you for domain, range, asymptote, and behavior.
Do we need to sketch the graph too?
Yes.
Okay.
Sketching the graph will help you determine all of these, right, ma?
I know, I was just asking if we have to do it.
Would be nice if you understand. I'm happy, but I just want these details. This is plus. D minus and okay, let's see. Infinity. Really, Manav?
What?
Okay. Somewhere something is lost on that end behavior, I feel. Other than that, things are right. But the end behavior, there is no does not exist, right?
No, but
Oh, the
it can,
negative infinity. Okay.
yeah, because like
Okay,
there's
okay.
nothing.
See, instead of that, what you need to do is you have to write about 2 plus, I think.
Hmm?
I'll show you. I'll show you.
Oh, we have to do one-sided limit too.
Correct. End behavior means because
Oh.
it starts only there, right?
Oh wait, so I don't do negative infinity or infinity?
Where 1 minute, Amma. All real numbers.
Because I think in
Asymptote is
school,
not x equal to 0. Hey, Sushank, this is not the graph, right? Sushank. Sushank,
Yeah.
that's not the graph, right? I asked you for this one.
Oh.
You keep on answering for the same one. The
Sorry,
infinity
I'm
method.
just visually looking at what's
wait,
on the
Miss
screen.
Priya, I think in school what they do, they just make, I think they make us do with infinity and the vertical asymptote.
Well, but several of those you'll get does not exist for logs, right, Amma? Minus for x equal to 2, 2. Yeah, Krish, that's right. Krish, that's right, Krish.
Oh,
So
do I just write the
at least
limit?
with the log, I would expect you to write like that. You see what I mean?
Yeah.
Our
And
usual,
exponential you write with infinity?
yeah, because there it will exist, right? So here, let's see this one. This one, first of all, it's a reflection. I would go ahead with this procedure only always. Reflection on x-axis because of the minus, and then vertical stretch by 2, then left right by 2. Okay, if that is the case, reflection on the x-axis, now what happens? The graph becomes this. This is my graph. Reflection on the x-axis, and then vertical stretch by 2. Vertical stretch by 2 means what happens? Let's see. Should have been like this, but there was a vertical stretch by 2 and then right by 2. Right, it moved by 2 means the graph asymptote would have moved like this. Okay, and then it stretched by 2 means it's more steeper. That's all it means. Vertical stretch by 2 means. So this is the final graph. Uh, Ashrita, where you don't understand, ma? So the domain is 2 to infinity, range is minus infinity to infinity, and then asymptote is x is equal to 2. End behavior you have to write a 2 plus, right? So as x tends to limit, x tends to 2 plus, what happens? F of x tends to infinity. Limit x tends to infinity. Left and the right you need to write. This is the left limit, this is the right limit. Manav, did I make it clear? Manav.
Yeah.
Krish,
Oh yeah, I got how to do it.
okay.
Wait, Miss Priya.
Uh,
Oh, so you only do for the things that do exist? Like
at
for
least on this
positive?
one, right? Because if you are, there is no way you can do the left side at all on a logarithmic graph, right?
At school, because we do it a bit differently, I think what they did is we do both, even including negative infinity and from the left
Infinity,
side.
but would it not be always does not exist for one of these?
Yeah, I know, but I'll just ask what I do on
Okay,
the
let me
test.
quickly verify on that. Because what does see many a time what is more important is what your AP college board expects. Let me quickly see whether I can try finding it. Otherwise, I'll let you know next week. For log graphs, right?
Yeah.
Maybe
I
pre-calculate.
think for school they make us do both, so we always get one that's infinity to infinity.
Uh, I felt like you should know how to write. You don't need to say does not exist is what I felt, but I can check. See, boundary of the domain on the right. Yes. So you have to only write, meaning that the does not exist will not be valid. Okay. It meaning the left boundary and the right boundary you need to consider. Am I making sense?
Yeah.
Meaning for a parent graph, meaning what I'm saying is left boundary, right boundary means for a parent graph as well, you have to say limit extending to 0 plus f of x tends to minus infinity like that. Limit right boundary is x tends to infinity, f of x tends to infinity. Make sense? Manav, you're muted. This is the right way. Left boundary, right boundary you need to
Oh,
consider.
so you just take the domain and use that?
What is it?
You just take the domain and use that?
Yes, take the domain and use that, because this tells you your left and the right boundary, right? 2 plus here. Sometimes, see the previous graph that we drew, right? It was 2 minus, right? Because it was like this. Make sense? Or 4
Yeah.
minus it was, right?
Yeah.
So there you will see minus infinity is the left boundary. Right boundary is 4 minus. Make sense?
Yeah. Yeah.
Okay. I can once verify and say, but quickly checking, I'm seeing you should be able to tell for logarithmic functions, the left and the right boundary is what tells about the end behavior. Okay, now what did I want to cover? I want to go back to. Okay, how about this? This is a good one. Let me see, guys. You can use technology. Would you mind using technology and telling me asymptote domain and end behavior for this one? Log of absolute value of x minus 5. Log of absolute value of x minus 5. Do you think you can do this? Try, guys. Let me know
Also,
if
we
you don't
just
know.
find the same.
You can use the technology. Technology means you can use the TI-84 calculator to understand the graph. How does it look? And based on that, you can tell me the domain range. Sahil, I really want you to answer that as well, Sahit. You can use the calculator. Domain. Shri, what are you doing?
I'm with you.
Asymptote and then end behavior. All that I need. Lopa, did you send the topics that you needed?
Oh, is it okay if I send after class? I don't really have.
Yeah. Sure, ma.
Can I go get my calculator from downstairs?
Yeah, go. Let me know if you're stuck or needing help. Go ahead. Can I get the answers, guys? Yeah, some of them I got it. Okay. So this one would be, yeah, let me see the domain, how you guys do. You can use your own, you can use the calculator because it's a little tricky. You want me to show it to you on the calculator, you have to let me know as well. Oh wow. Good job, Sahil, but you missed the U in between. You have to use a U in between, right? Range is correct. X tends to infinity, y tends to infinity, x tends to minus infinity. Oh yeah, that's right. Right, Krish. Sahil, did you understand how to write the end behavior, Sahil?
Yeah, I just saw it. I'm gonna do it right now.
Okay. I'll let you know if it's hard. Shragvi, did you write? Shri, did you write?
I'm sending mine.
Where's the algebra?
Yeah.
We could have done it in range, and I finally understand where. One of them is the input of x, the other is the input of y. From where?
Hmm. I will definitely help. Uh, how range is becoming minus infinity to 3? Sushank, where did the 3 come from?
I that's what I got from my like
Yeah,
you.
Sahil, that's correct, Sahil. Parvini. Okay. I'm going to draw this. Parvini, I really like the way you're thinking, but that's not correct, ma. See, here the graph is going to look something like this, right? X, the 5. So the graph is going to look something like this, right? Right? If this is the case, right? For the domain, you go from minus infinity to 5. At 5, it becomes undefined, right? So minus infinity, comma 5, both are not included. Union 5 to infinity. Any questions here? Next one, range is minus infinity to infinity. Range is minus infinity to infinity. The asymptote is at x equal to 5, right? Sushank, how did you get the 3?
Oh, I think I meant to put 5 instead
5.
of.
Okay. End behavior, when you think about it, Parvini, I wanted to tell you, Shragvi, I'm not getting answers from you. Are you understanding?
Yeah, I get it. I'm
Okay,
sending
so coming to the end behavior, it
Miss
is
Priya,
always the left boundary, right boundary. That's all. Yes, ma?
I don't understand the range for this one.
Oh, how are you getting the graph? Did
My
you
graph
see?
looks like this.
Your graph looks like. Wait, let me see. Where are you seeing? Your graph looks like something like this, what I drew, right? Not.
No, it looks like. Can I draw it?
Yeah. Feel free to draw it on the board. We'll
It
discuss.
looks like no, it looks like this. It's like this, and then it has like the spot where it's like the lowest, and then it's like slowly increases.
Okay. Let me go back to the calculator. Okay, this will go, guys. Give me a minute. I'm going to show it in the calculator. I'll take a screenshot of this. Give me a minute, okay? This is going to go and it's okay, okay? So I'm going to show it in the calculator. I want to go to this one. So let me go here. Chrome. Yeah. Can I go to, I will go to TA84 calc. These all take up time. That's okay. So here I will go to y equal to log. Where is the absolute value function? Anybody can help me, guys. Where is the absolute value function?
You have to go to math
Math.
and num.
Do we have ABS?
You have to go to num.
Okay, I don't remember on top of my head. Very on. Thanks. Okay, so absolute value function of x minus, what was it? X minus 5, right?
Yeah.
I'm sorry, guys. Log of, go to math. Num, absolute value function, x minus 5. Where is this x? X minus 5. That's it, right? I'm going to close, enter. Now graph. See, it just goes undefined, right? It doesn't go down, that's all. So if you want to see the change, right? Did you adjust the window and check? You don't have to go to minus 10, right? It can just be a negative 3. Okay, x max can be okay 10, xscl can be 1, y min can be Oh, see. What?
Can I get an extension for my writing?
Yeah.
Because I did something minus.
Yeah. So this is going to be minus 10, x min, x max, but y min need not be minus 10. So there I can have minus 3, y max need not be minus 10, right guys? It can be 3. So we are very clear of what is happening there. It can be just a 3. YSCL can be 0.25. Okay, now graph it. Do you see, Manav?
I think I get it. It'll just go on forever until it
Yeah,
reaches
it just
5.
goes on
I
forever,
get
and
it.
here it doesn't go down either. So here at this point it is
So
undefined, right?
so any scenario for a log is always range infinity, infinity?
Yeah, this is minus infinity, infinity. Make sense?
Yeah.
So limit end behavior will be extending to minus infinity is your left limit, right? So where it is going? It's going to f of x is tending to infinity, right? Similarly, limit extending to plus infinity, f of x is tending to again infinity. Make sense?
Yeah. Yeah.
Make sense? Okay. So stop share. Okay, let me come back to our
Miss Priya,
Yama.
so for the end behavior, you would only write like x tending to like 2 or something if there was a clear vertical asymptote?
Correct. If there was a clear, meaning here as well, there is an asymptote, but your leftmost point is here. What is your leftmost point? What is your rightmost point? That's the only consideration. Suppose your graph is like this, let's say. What is your leftmost point of the graph? This is your leftmost point. What is your rightmost point? This. You got it?
Oh, okay.
Only your left, right. See what is your left and right. Here it is, let's say this is 2. Now I will say limit extending to 2 plus limit extending to infinity for my right. Make sense?
Yeah.
Wherever the h is, wherever the asymptote is. But suppose if your graph is like this, what will you do? Here, your left limit is minus infinity to 5 minus. You got it? So, left limit is extending to minus infinity. Right limit is extending to 5 minus. Make sense?
Yeah.
Okay. Can I move on?
Yeah.
Okay, that consumed a lot of time, guys, than what I thought. Okay. Now, coming to logarithmic function manipulations. Logarithmic function manipulations. This is going to be a little intense. Ashrita, you're not answering, Ashrita. What is that you're not getting? You have to be blunt. Okay. Now, I'm going to go over the product property, quotient property, and the power property very quickly. Okay. Product property, quotient property, and power property. Remember our product property? Log base b, log xy base b can be written as log b of x plus log y base b. Quotient property would be, this is all from algebra 2. We are still reviewing algebra 2. Log b, log x by y base b will be written as log x base b minus log y base b, correct? And then what is that power property? Power property says log base b x power of y can be written as y log x base b. Any questions, guys? Any question on this?
No.
Okay. Similarly, other ways as well true, in the sense if you are given something like this, log 3 of log 4 base 3 plus log 5 base 3, you can write it out as log 20 base 3. Why? These two can be multiplied. Similarly, if they have log 4 by 2, let's say base is 6. In this case, you can write this out as log 4 base 6 minus log 2 base 6. You can split it like that, or this is condensing. This is you're condensing it, right? This is you're expanding it. Depends on what you need to do. Here you're expanding it. Okay, doing it the other way is you're condensing it. Sometimes they'll ask you to condense, sometimes you might have to expand. Can I move on? Okay, you'll have to remember these guys, okay? We are going to get into very complicated ones. Suppose you have, if you're asked to expand this 4x square y, this one I will do. Log 4x square y. How will I expand? Log 4 plus log x square plus log y. However, there is a power property here. So log 4 plus 2 log x plus log y. Any questions here? Lopa, did you get that?
Yeah, I did.
Okay. So now let me go ahead and give you some hard ones. How about, let me see this one. See whether you can do this. I'll help you if you can't. Let's see this one. How about, I'm going to write it bigger if you want. I would like to see answers from every one of you on this. Plus half log y plus 1 base 2. How to do this one? How to do this one?
Are we condensing or expanding?
What are you doing? You tell me.
Condensing?
Yeah, you're going to condense it because it's already expanded, right? So there is a plus. So what happens? First of all, this power needs to go. Do you want me to do or you want to try?
No, I'm fine with anything.
Okay. Are you able to do? Are you stuck? Let me know, guys. Is that it, Siddhi? Square root of y plus 1.
Miss Priya, I'm not sure if what I got was correct. Can you go
Yeah,
over?
I'll help you otherwise. Wait a minute. Ashrita log base 2. Not really. Lopa. Yes, sure, Lopa. I saw your message. Sushank, Shri, I'm not getting even a single answer from you. Sahil,
I thought I sent it. Hold on.
yes, I'll go ahead and do this, guys. So when you think about it, first of all, the power property, see
Miss
the
Priya?
number. Yeah,
I sent my answer.
that's right. Shri, looks like you are good. So here, first of all, Krish, did you get it?
Yeah.
Okay, so the power property has to be applied first, the reverse of the power property, right? Not really, Manav. Yeah, yours is correct, Krish. Okay, so here this power property will go
Oh,
here,
I
right?
forgot
You're
the
doing,
1/2.
huh?
I forgot the 1/2.
Yeah. Many of you forgot the 1/2. So y plus 1 power 1/2. What is power 1/2 as a radical, right? Both are log 2. So first let me multiply them. X square y plus 1 power half, right? Now this is log base 2, right? I can write this out as log base 2 x square times square root of y plus 1. Correct, guys? Any
Yeah.
questions on this?
Miss Priya, I'm confused. How did it become x squared and then like y plus 1 to the power of 1/2?
Okay, where did you not understand, ma? This one, 2
Yeah.
goes up, right? So that becomes x squared. Now, x square, y plus 1 power half, both have log 2, right? Log base
Yeah.
2. So I can multiply them. X square times y plus 1 power half, all within this log base 2, correct?
Yeah.
Now, what is y plus 1 power half? This is square root of y plus 1.
Okay, I get it now.
Okay. Now, let's see. See, this is going to be a little intense. I told you, right? So, let's see this one. Try this one, guys. I'll give you two. Whoever wants to pick the easier one, pick and do. If you want to try the harder one, you can try. Two questions I'm going to give. You're going to do both. Whoever wants to do whatever, I'm fine. But at least one you have to do for me in this class. Let's see. There are two questions. It is a little intense than algebra 2. Then change of base we'll discuss as well. Uh-huh. That is correct, Sahil. The first one is correct. Can you do the next one, Sahil?
Yeah, I'm still working on it.
Sure. X cube by x cube. Not really, Sushank. Sushank, that is cube root, right? Cube root is not power 3, right?
No, that's what I put. Like it has the radical with 3 on it, right?
Yeah, but you have put x cube 5 plus 5, right?
Oh, wait. How would I say that? Would I say cube root?
Let me go ahead and do that for you.
Because I thought it was just called cubed if you're putting it in the radical thing.
No, right? See here, the answer itself changes, right? So here, this is division, right?
No, I know what it is. I put that symbol. I just didn't know what it was called, so I put cubed.
No, right? The answer also doesn't seem right to me. I'm feeling. Let's see. You just correct me if I'm wrong as well. If my understanding is incorrect. So basically, this is what it is, right? Now, this one, right, is a power. So log x plus 5 power 1 by 3 minus log y square. We have discussed the power property to bring it here, right? So 1 by 3 times log x plus 5 minus 2 log y, right? So Shank.
Should I do the algebra book?
Oh, yeah.
One?
Uh-huh. You got it? Okay, for the second one, Shragvi, did you get that?
No, I did the first
Priya?
one. I'm doing the
Wait,
second
Miss
one.
Priya?
One, Shagvi, I didn't hear you, Mana. 1 minute. What is that, Shagvi?
Wait, where'd you get X? Oh, that's a different question.
Two questions I gave you. This one was
Oh,
easy. This one was hard.
can I see the say the answers to the second one. It's
Second
kind of
one.
hard.
Yes, absolutely, Mano. Shravvi, what was that on the first one?
Yeah, I got that answer. I'm doing the second one.
Oh, nice. Okay. Okay, guys. So let me see. Let me go ahead and do the second one, maybe. So this one is first, this is a power. You can change it to a power, right? So log base 3 ab square power 2 minus 3 log c base 3. Again, this number is actually a power. That can be plus log d power 1 by 3 base 3. Now all have log 3 I'm seeing. However, I forgot to switch this power. So I'm going to rewrite this. Log a square b power of 4 minus log c base c log c cube base, the 3 is a c cube, and then this is cube root of d, right? Now all are in log 3. So I can see one is in division, one is in multiplication. See here I can multiply these two. How do I do it? Log 3, log base 3, a square b power of 4 times whatever is in here, cube root of d. And then the minus converts to division by c cube. Any questions, guys? Any questions?
No, Miss Priya.
Lopa, did you get that?
Yeah, I understand.
Manav, did you get that answer?
Yeah, yes, I got that.
Sahil, did you get that answer? Sahil, did you get that answer? Sahil, you're muted if you're talking, Sahil. Okay, let's see this one. Suppose if I have, okay, if I want to change the base, suppose I want to calculate this, I want to change the base. What do I do? Log, do you remember the change of base formula, guys?
Yeah.
Okay, so that is quite important. Let's see. If you have some base b, okay, suppose let's say if you have base b um, of, let's say, a number maybe a, okay, if you have it, right, you can change it to a common different, let's say log base c of a, meaning log a base c divided by the base log base c, meaning you're converting it to a common base. However, now you don't need this b separately. Okay, so here sometimes you might be asked like this. You can convert it to ln or log. This is equal to log base 10. When I put log, it's always base 10. Log 2 by log 5. But it's the same as ln 2 by ln 5. Base can be anything. Here it is e, here it is 10. Any questions? Okay, let's try this one. Suppose if I give you an equation like this. I really want you to understand how we will complete only this one. Okay, that's okay. That's okay. Let's see this one. Okay, suppose let's say log 4x base 2. Suppose if I have log 4x base 2. How do I talk about graphing this? Meaning I want to graph this. Would I be able to graph it and tell the transformation? Similarly, I also want to plot ln of x minus 4 the whole square. This is f of x, this is g of x. Can we plot these two graphs? Can we plot these two graphs? Can we plot these two graphs?
Yeah.
How do you get to plot these graphs? Can I change it to a log function? If I want to change it to a log function, it becomes log base 10 4x by log 2 base 10. I don't need to do that. So what other ways can I do this? I'll wait for you to think and tell me what other ways can I use to graph this. There's some other easier way. What is that?
Change it to log base 2.
This is okay. I don't want to
Change it
change
to-
bases at all. Yeah, I don't want to
No,
change
just
base.
change it to log 2 base 2 4 plus log.
That
F.
makes sense. Log base 2 of 4. This is multiplication, right? I can expand it. So log x base 2. Now, this one, right? The 4 can be written as 2 squared. So log 2 square base 2 plus log x base 2. Here, this one, right? This cancels out and become 2 plus log x base 2. Do you see it, guys? So basically, what is this? If you think log x base 2 is your parent function, it is just going up by 2. That's it. Going up by 2. Provided log x base 2 is your parent function, then it is a vertical shift of just 2 units. How about this one? This one? I can write it out as 2 times ln x minus 4. So what are the transformations in here? Vertical, stretch by 2, right by 4. Any questions? So, whenever you are given logarithmic functions where you can use the product property, quotient property, or the power property, you can always predict the transformations well, provided you transform them to the way you want. Can I move on? How about this? Okay, I want you to do this one. Okay, let's see this one. Log 18 minus 9x base 3. Log 18 minus 9x base 3. I'll wait, guys. So what do you think about what are the transformations from the parent graph? Can we try, guys? Can you try and send the answers and then we'll finish up there. We did only, what did we do today? We did only 2.13. Oh, 2.13. I need to do 113, 14, 15. I'll do it next week. Did you get it? To get it, if you get it, you can leave. Let's see. Sahil. Sahil, but it cannot be 2 minus x, right, Sahil? It
Wait,
cannot.
Miss Priya, wait, do I just show my graph?
Yeah, you can just say what are the transformations. That's more than enough. That will tell
Oh.
me whether you understood or not, right?
Okay.
Sahil, it cannot be 2 minus x, right, Sahil? Yours is correct, but what are the transformations? Can you send the list of transformations and then you can leave, guys? Do I need to do? Then you have to say. Siddhi, you're able to do or you need help? Lopa, are you able to do, ma?
Yeah, I'm
Uh,
doing it right now.
Manav, yeah, I think that's right, Manav. So you took out the 9. You took out the 9. It became 2 minus x, which is nice. But then it cannot be 2 minus x. So what do I do? So I take out the minus 1 as well, right? Now that becomes x minus 2. So here, what I would say, I'll start with this. It is a reflection on
Y-axis.
y-axis, vertical stretch by 9, and
Isn't it
then
horizontal?
I'm sorry. Horizontal compression by 1 by 9, correct?
Oh,
And
oh,
then
I'm supposed to say 1/9.
yes, right by 2. Horizontal compression by 1 by 9.
But in pre-calc, you're supposed to say dilation, right?
Come
Or
again?
can you? In pre-calc, my teacher said
Ah,
you have to use
wait a minute. Oh,
dilation.
but you can change this, right? Wait. I can change this further, right? I don't need to. See, there is a base 3, right? Did you think about it?
Yeah.
There is a base of 3 and that's a 9, right? How can I change it? There are other ways of looking at it. There's a
You can keep it as 2 minus x and
Let
take
me
like.
show you. I'll show you. I did not see the base 3 here. Okay, let's see this one. So I can really write it down as log 3 of the minus 9 and then this is multiplication, right? Plus log of x minus 2 base 3. Here log minus 9 I can write it as 3 square, right? Do you see?
You can't
Can I
have a
write it?
negative in a log though.
What is it?
You can't have a negative in
Negative
a
in a
log.
log, yes. So before itself, rather than writing minus 9, I can write it out as 2 minus x and 9. You cannot have that minus 9 in here. So I can write it as a 9, but I can write this as a 2 minus x for now. But this will be log base 3, 3 square. This one would be log base 3, 2 minus x. So this one sums up to just 2 plus log base 3, 2 minus x. But then finally I can change it to 2 minus 2 plus this one. I can write it like this, right, Mana?
Oh yeah.
In this case, I can say there is a there's a reflection on the y-axis. Then what? Up by 2 and then right by 2. Make sense?
Yeah.
Yeah. So see, it's a lot of practice that gets you there. So whenever you see 9, 3, those all can be quickly cancelled out as well. So more practice will really help. Any questions here?
Miss Priya,
Yama?
how did you go from the log 3 base 3 to the exponent 2?
Okay, ma. 9 is expressed as 3 square, right?
Yeah.
By property, log, if it is like this, right, this reduces completely, this goes off and it goes to a 2. The value becomes 2.
Oh,
Got it?
what if like it wasn't 2 and it was like 3? Then would it just
This
become 3?
one, this one,
Yeah.
then it becomes 3. Whatever be the power, it becomes that.
Okay.
Make sense?
Yeah.
Yeah. As Manav pointed, so I didn't want the minus 9 in here. That's why the minus was retained here itself. Make sense?
Yeah.
Okay, I'll stop here, guys, and I'll continue logarithmic regression, inequalities, regression, and semi-log plots next week.
Thank you.
Bye, guys. If you have
Goodbye.
questions, stay.
Bye, Miss Priya. Thank you.
Bye, Ma. Hey, did you get it, Stragvi? It's a little different. Okay, she's gone. Okay. Hi.